So we were talking about big telescopes. So now we're going to talk about bigger telescopes. The goal for bigger and bigger telescopes goes back a long way. Astronomers for a long time had been, realizing you need bigger telescopes to see things, but a lot of the European astronomers were fairly content with the telescopes that they had and making the discoveries that they were making. It was really the Americans, in particular George Ellery Hale, that was really pushing really big telescopes. And that set the stage for even bigger telescopes. And so even bigger telescopes were built, and the Americans started ending up leading with the telescopes, particularly when they got around to the Palomar telescope. About Palomar telescope, and then eventually the Russians, the Soviet Union wanted to do something even bigger, but their telescope didn't really work quite as well as the Palomar telescope. So even though their telescope was slightly larger, most astronomers still regarded the telescope at Mount Palomar to be the premier instrument. In fact, Palomar is still a spectacular instrument. But the problem is they wanted something bigger. And they were reaching the limit as to how big a telescope could get, at least with the technology at the time. And so they started thinking about it and said, well, the problem is that we've got this telescope and the light from the mirror is focusing all up to another mirror and then directed somewhere. And so they got to wondering, would it be possible to use multiple mirrors focusing light all to the same spot? And so what would you call such a thing? Well, in the typical way astronomers name a telescope with multiple mirrors, we name things very boringly. Okay, it's called the multiple mirror telescope. And so here we have 6 mirrors that all focus light all to the same spot in the middle. And so this telescope was built as a test bed. It wasn't the final product. It was the test bed to indicate that this technology would actually work. And it did. Now, the multiple mirror telescope had various issues with it, but it did prove that this basic idea that multiple mirrors could be focused together would work. Now, you could tilt the telescope, and then if the temperature changed and it expanded, or if gravity sagged on it, or something happened to make it go out of focus a little bit, then you can fix that. And so by adjusting each of these little mirrors slightly. Well, that eventually morphed into the Keck telescope. This is at Mauna Kea in Hawaii, and there's 2 of these identical Keck telescopes, and we call them Keck 1 and Keck 2. And each one of them is made up of a mirror, and the mirror, each one of these segments of the mirror is a separate, independently adjusted piece of polished material, actually aluminite glass. But each one of them is adjustable. So what you do is you point the telescope up into space. There's a laser that fires up here and causes a little fluorescing spot in the upper atmosphere, and you point the telescope at that spot, and then each of these mirrors can be slightly adjusted to bring the entire thing into a proper parabolic shape. And so now you can focus it by adjusting the mirror. And so now you can build much bigger telescopes. In fact, each of these mirrors is itself about 7 or 8 feet across. So this is a huge instrument right here. And so that's the Keck telescope in Hawaii. Well, not to be outdone, they realized you could do even better. Okay. The problem was going bigger because the Keck telescope, Keck 1 and Keck 2, were amazingly expensive. And so an interesting thing happened, and that is in Texas, we got money. University of Chicago and Texas together got money to build a telescope. It's called the Hobby-Eberly Telescope. After Bill Hobby, Lieutenant Governor of Texas, helped to get it. And the way that it works is it just points in one direction in space. Instead of pointing in all different directions, the way that other telescopes do, it points up in one direction. You can turn in azimuth, but it's always fixed in altitude. It's always the same angle. And so you have to kind of wait until what you want to look at is that angle. Well, it's not quite that bad, because what happens is the mirror down here is not 100 is not a really perfect parabola. It's more of a spherical mirror. So what you do is you can move the detector along this path up here. So when the detector's at the bottom, then light reflects off of this part of the mirror, so from this part of the sky and up here. When you move the detector up near the top, then light reflects off of that part from up in this angle. And so even though the telescope only points at one angle, by moving the detector back and forth, you can sweep across the sky. And so this is a way cheaper way of doing it. And so the Hobby-Eberly telescope, even though the mirror is actually bigger than the Keck telescope mirror, then what happens is you end up with a much less expensive thing. Similar to the Keck, you have this tower up here that fires a laser beam up into space, and you focus on it. Okay, it's located at McDonald Observatory in far west Texas. It's operated by the University of Texas at Austin. Even though this is out near Fort Davis, it's the closest town. So it's middle of nowhere, West Texas. Fort Davis, Marfa, Alpine, those are the closest towns to it. The interesting story here is that McDonald was a wealthy person wanting to donate money to build an observatory, and he donated to the University of Texas. Well, at the time, University of Texas didn't even have any astronomers, so they had to hire astronomers and build an astronomy department. And so they built it out in the middle of nowhere, and the Hobby-Eberly Telescope is located there. Well, it's not the only thing there. That's the Hobby-Eberly Telescope on that right there. This is actually a photograph from a trip to a field trip out to that area. And so that was the original McDonald Observatory. Originally, it was just that one telescope up there was the first telescope, and then they built a bigger one, and then several smaller ones up there. And so that was the McDonald Observatory at Mount Locke. Mount Locke is pretty much full, so when they built another telescope, they had to build it on the adjacent mountain, and it's sort of in the saddle between the two is a visitor center. So you can actually go out there, and the visitor center has exhibits, and you can take a tour up to the bigger telescopes up there. And at night, they occasionally have star parties at the visitor center in the middle there. Here we actually have the astronomy club that was visiting out at the McDonald Observatory, standing in front of the dome. And here we have some technicians in the process of installing the mirror segments for the Hobby-Eberly Telescope. And you can sort of see the dome of the Hobby-Eberly Telescope right there. The Hobby-Eberly Telescope was built in Texas and was at the time the largest mirrored instrument. And they decided, though, the problem was that only can see things in the northern hemisphere. So astronomers managed to get money together to build a very large telescope in South Africa. And the name of this is the South African Large Telescope. And so it's based on the same design as the Hobby-Eberly Telescope, and so it's got the same sort of setup. It's fixed at a certain altitude of elevation here, where it's looking, and the detector can run back and forth on a little rail right there. At one time, the 200-inch telescope at Mount Palomar was the largest telescope on Earth. It was named the Hale telescope, but it is now near the bottom of this list right here of telescopes. The Russian telescope that they built to kind of compete with it is right there. And then the multiple mirror telescope, which was later replaced by another instrument, and they wanted to keep the same acronym. So the multiple mirror telescope was MMT, so they call this one the Magnum Mirror Telescope. And then we have these twin telescopes in the northern and southern hemisphere. They call them Gemini North and Gemini South. And then in South America, there is a telescope that's actually four pretty decent-sized telescopes that strung together make a very large telescope. The name of this is the Very Large Telescope. And then we have the South African Large Telescope here, Hobby-Eberly Telescope, and one of the premier instruments at the moment is a telescope that was really two very large telescopes that looked like a giant set of binoculars, and that's called the Large Binocular Telescope, and that's in Mount Graham, Arizona. My wife gives me fits every time I talk about astronomy stuff because she teaches anatomy and physiology, and everything has these really weird names. And so in astronomy, it's like the multiple mirror telescope, the very large telescope, the large binocular telescope. There's a very big telescope that just looks at the zenith, and that's called the Large Zenith Telescope. And so she says we just have no imagination, but it's very descriptive as to what all these things are. Okay. So while the Keck or the Hale telescope was the largest telescope on Earth, from 1948 to 1976, and when I started school, it was the biggest telescope. It's now the 19th biggest telescope. There's 18 telescopes bigger. The key to all of that was the ability to build these segmented mirrors. So you don't have just one. Not all telescopes have finished being built. The Giant Magellan Telescope is being built in Chile, funded by the Carnegie Foundation, the National Science Foundation, and several others. Two Texas universities are involved in this, Texas A&M University and University of Texas at Austin. It's going to have 7 8.4 meter mirrors, and that's really huge in and of itself. But it's going to have 7 of those mirrors arranged in to make a bigger mirror. So the effective aperture is going to be almost 25 meters across. That means it's going to have a mirror 80 feet in diameter. And so this thing is going to be gigantic. It's expected to be finished end of this year, though I think that's been put on hold a little bit with the coronavirus, so I believe it's not really going to see first light until later, maybe next year. They also have plans to build a 30-meter diameter telescope. In the way we typically name things in astronomy, it's called the 30-meter telescope. And the plan is to build it on top of Mauna Kea in Hawaii. The original plan was to start construction in 2012, and they have not yet started construction, they're just about to. It was delayed due to budgetary problems, overrunning the budget, and running into a problem in that there was legal challenges to building this very large thing on top of the mountain. The European Southern Observatory is in the process of building an extremely large telescope that's going to be 42 meters in diameter, and that is phenomenal. That's like 130 feet across mirror. It's being built real close to the Very Large Telescope in Chile, and construction began in 2012. It's going to be completed in 2025. I'll say more about the Very Large Telescope in a later lecture, but this one's called the Extremely Large Telescope. Astronomers are a little bit boring in how we name things. So